In section 3 and section 4 of this chapter, we're going to cover the data link layer as part of the network access. And as we said before, the network access in the TCP/IP protocol model corresponds to the physical and data link layer in the ISO OSI reference model. So now we're going to cover the data link layer. So the data link layer is used to provide node-to-node communication inside the same network, and in that it actually accepts the packets from the network layer, and then it organizes the access to the network medium between multiple users. So again, it actually accepts the layer 3 packets from the network layer, package the packets into frames, and then control the access of the network for these frames from multiple users. Um, so again, in the OSI reference model, the data link layer and the physical layer constitute the network access layer. However, if we zoom inside the data link layer, we will find that the data link layer is divided into two sub-layers. One is logical link control sublayer, and the other is MAC sublayer, or medium access control sublayer. The reason for dividing the data link layer into two sublayers is to facilitate the access of between the network layer protocols and the different types of media in the physical layer. In other words, the logical link control sublayer accepts the different protocols, whether it's IP version 4, IP version 6, and so on, from the network layer, frame that independently from the physical medium, and then gives this frame to the MAC layer, which will then, depending on the physical medium, which will organize the access to the physical medium amongst the different users. So the logical link control tends to be medium independent, whereas the MAC sublayer tends to be medium dependent. Another thing we have to pay attention to here is that all the Ethernet standards, which we will talk about, 802.3, 802.11, or 802.15, all the LAN standards that we will talk about, or we talked about before, they cover the physical layer and the MAC sublayer, and they are separate from the logical link control sublayer. The reason is these standards, they define the medium related issues, and they are very much medium dependent, in which case they are separate from the logical link control sublayer, which is medium independent. So the data link layer protocols, they specify the encapsulation and decapsulation of frames amongst the different types of medium. So if we imagine this particular example where we need to transfer information from Paris all the way to Japan, so we can imagine that we will potentially pass through different types of medium. So for example, we have here like wired connected to router, and this router is then accesses the internet through an internet service provider which use some kind of a TV network. From the TV network, we can connect to satellite networks and so on. Then we will deal with wireless transmission, and then from wireless to the other laptop in Japan. So in that case, the data link layer deals with the different types of media, and it frames or encapsulate the frame depending on the different types of medium. As we can see, for each type of medium, it's a different frame, which is suitable for transmission within this network of a specific physical medium. So this concept is illustrated in this example. So both the encapsulation and decapsulation of frame happens in every type of network. So, so from In this Ethernet connection, the frame is encapsulated using header and trailer, which is suitable for Ethernet. Then through this WAN connection that connects two routers together, the encapsulation of frames will be different and possibly using different data link layer standards, as we will see later, in which case the WAN header and WAN trailer both will have to change. So in every hop along the way, there is encapsulation and decapsulation that happens within the data link layer. Unlike the higher layers, including the network layer, as we will see later on. So in that regard, the data link layer accepts the frame from the higher layer, forms the encapsulation of this frame using the header and trailer, which is suitable for this physical medium, and then it forwards the packet using the appropriate timing and coordination to facilitate the access of that medium amongst potentially multiple users, which is part of the which is done through the MAC layer, as we will see later on. So the OSI reference model defines in abstract way the data link layer structure to include frame header and frame trailer. As we see here, the data link layer is the only layer that has both frame header and frame trailer, and we will recognize that when we talk about the higher layer protocol data units. So the OSI reference model defines what fields are included in the frame header, what fields are included in the trailer, and what is the function of each one in abstract way. So it defines the header to include these four fields, and which includes the frame start and frame stop. So the frame start and frame stop, they indicate to the receiver that this is the start of a new frame and this is the end of the new frame. So the frame start and stop simply defines the beginning and end of a specific frame. After the frame start comes the addressing, and the addressing here is very important to identify the node or the host or the workstation on the network that this frame is targeted to. And it also includes the source address in case of any error during transmission. We need to send back the frame to the source. This type field is very important because it indicates the protocol in the higher layer. So this type indicates the protocol in the network layer. So for example, if we use in the network layer IP version 4, this type field will include an identifier that this frame includes data which is formatted using IP version 4. If it's IP version 6, this type will have a different identifier to show that this data is formatted using IP version 6. The control field defines a set of flags and values to facilitate flow control, and this is used between the sender and receiver to make sure that the speed of transmission is not overwhelming to the receiver. As we have defined before, flow control is concerned with the pace of transmission of the frame. The trailer includes two simple fields: the error detection, which is used simply for detecting any type of error. If there is an error, then we need to send back to the source to indicate to the source that the source needs to send the frame again. And then the frame stop, which marks the end of the frame. So the data link layer or the layer 2 standards, they use different techniques to develop these standards. So unlike IETF organization, which standardizes the protocols in the higher layers, network layer, and so on, the data link layer standards are developed through organizations like IEEE or ISO, and they use numbers like this to indicate the data link layer protocol, whereas IETF, they use what we call request for comment, or RFC, to define protocols in the higher layers like TCP or UDP or IP and so on, as we will talk in later chapters. The data link layer standards, they are developed through IEEE and ISO and ITU, and they tend to have identification numbers like this.